Okay, so there was one more transitional fossil that I missed that has been proposed, and that was Archaeopteryx. And the problem with this one is there's lots of birds that have teeth, and there's lots of birds that have claws on them. So it really you can't say it's like, a precursor to these birds. Um, when they've got the same things, that it could be just a bird. But the biggest damning evidence for it is there are birds that haven't got these features and are modern birds, and they will actually have been found in the fossil record before this creature. So modern birds appearing before Archaeopteryx. So it's basically, obviously, just an extinct bird. Okay, so what about um, homology? What has actually been put forward is that homology, when we look at the fossils and put them together, we're looking at uh, how they all look together, and we're looking for progression in the fossil record. The creator of the who came up with antibiotic resistance, Ernest Cain, he basically says evolution. He rejected evolution. He says it's a very feeble attempt based on flimsy assumptions, mainly morphological, anatomical nature. So he thinks it can hardly be called a theory. I would rather believe in theories than in such wild speculation. So he was pretty damning on it. And what he was saying here is morphological anatomical nature. And he was talking about the homology evidence that they try and say. But this is the issue that paleontologists have. Okay, they're trying to find some sort of evidence, and this is the problems. We'll have a look at what some of the problems are. If we look at dogs, here's a Great Dane there, and different types of dogs, we can see that they are very, very, they're definitely a kind because they can breed together, but there's lots of these species of them. So we have a bulldog here, and it has an incredibly different skeletal structure. And if you were digging and you saw these different bones when you were digging, and these were buried millions of years ago, and you were trying to create a tree, or you were trying to put them into groupings just based on what they look like, you would assume that these are different creatures altogether, some of these. It would be nearly impossible, unless you knew what these creatures were, to actually say, yeah, they're all dogs and they can all breed together. Okay, so this is where the problem is. It's very, very hard to tell from the bones that they're the same type of creature if you dug them up, because they're all very, very dissimilar. Now, creationists believe that the biblical kind would have been like a wolf or something, and it could have even been more extreme, but it would have had all the DNA of these different types. But when you look at digging up the bones, you can basically make the bones tell any story you want. So these guys who are digging up these fossils are trying to put them into some sort of order of this comes from this and this is related to this, but really they're dealing with bones of dead animals, and we even know from looking at dog species that it's really, really hard to tell from their skeletons and their skulls that they actually are even related. Okay, and this is a real problem. I think you've got to be pretty much not naive about this. So, what is this homogeneous thing? Well, homogeny was if you have, it's proposed, if you have the same structure, so you've got all these digits, and you're saying man came from an animal, an ancestor that had 5 digits. Okay, and you're trying to say they look the same, so they must be the same ancestor. But what is actually happening with homology? Are these creatures that look the same skeletally, when you put skeletons together, are they actually have a common ancestor? Just because they have a similar bone structure. So, so this is what it's saying here. Their same basic structure has common origin. They should have common developmental history, surely. Okay, just if they've got a common, if they're a common origin and they've got the same looking features, then surely they have the same developmental and they use the same genes if they come from commonality. But what is actually they've found is it doesn't happen. Just because the bones look the same and the creatures look the same, they haven't got the same genes where they were creating these things from. And in fact, this biologist said it's the rule rather than the exception that homologous structures form from their same initial states. So it's actually it's not common at all. When you have a look at the ancestors where 5-digit creatures have come from, the penadactyl limbs, which mankind's supposed to have, and lots of creatures are supposed to have, you see that these creatures, they don't, these are supposed to be the ancestors, they don't have 5 digits. So it doesn't even work anyway. So if these are the proposed ancestors, but they don't have 5 digits, and the whole theory of homology is that homogeneous creatures, because they look the same, they have a common ancestor. Well, if the common ancestor doesn't have the same features, it's defeating itself, isn't it? The whole idea. So this is the problem. So you have all these different creatures. They have the same use, but they're not actually they're not actually the same. Okay, so there's heaps of different issues. When we have a look at human hand, for instance, which is a pentadactyl hand, it's got 5 digits, and so is a frog. They don't form from the same genes, and they don't develop the same way. The human one actually has develops it develops different again. So if we look at the homology of the penadactyl parts of our hand having 5 fingers, we can compare it with the human and frog having 5 fingers, but both have different. They've got different methods to form. Humans have a controlled cell death process called apoptosis, and basically what that is it's a controlled cell death where it eats away the gaps between the fingers and forms the fingers. Whereas the frogs, they actually grow their digits out. They both look the same, but have a completely different genes and ways for creating them. So even though the homogeny is the same, they have a completely different developmental and gene process. And as you can see, the actual ancestors, the proposed ancestors don't even have homogeny. So again, it falls over in so many different ways. Is there the same structure, different uses? Is there an actual way of looking at this and saying, well, if they've got different developmental processes, but their ancestors are actually different, is there a way of telling, is this evolution or not? Well, we know that just because they look the same, they don't always have the common ancestor, and they don't always have the genes for development, which is a real problem. So what does this actually point to more than anything? It actually points to that there must be a common designer because they look the same. This is actually far more powerful example. Engineers and designers use the same sort of work, common design in their work. The fact that the creatures have a very similar designs actually point to there is not more than one designer, but there's only one designer because of the homogeny. But they clearly are not evolving because they're not using the same genes. Now there's heaps of homogeneous in the universe, but scientists have pointed out that it doesn't point to evolution. This guy way back in the 18th century said the molecules in our universe also have a similarity, and he was arguing that the similarity, homogeny of the molecules is actually not proof for evolution at all. So we have a designer who makes similar uses of design, but uses different for different things. So they're the same, but they use different, have different uses. They look the same, but they're using different genes, and these creatures do not come from their proposed ancestors. So therefore, it's not evolution. This is, I think, homogeny is a dead fish in the water when it comes to scientific science, actual science.